So I work at a company called GoInstant. Our parent company is Salesforce. Are there any other Canadians here? Nice. So I'm from Victoria, BC, which most people know is just Vancouver. Yeah, I guess I'm the token Canadian speaker. So I'd like to talk to you today about, oh, hold on, my slides aren't working. Good old Reveal.js. Okay, I'm just going to turn on mirroring. Okay, so you can see what I can see. So the title says preventing cross-site scripting and CSRF. That's what those alphabet soup acronyms stand for. But what I'd really like to talk to you about is trust. And at Salesforce, we give this a capital T, and we put it on our #1 list of values, because trust is sort of the greater issue when you're talking about security. If you're running a platform as a service or software as a service, and your customers don't trust you, they're going to leave in droves. And if you look back at Salesforce's history, they actually had some incident where exactly that happened. So since then, they've become really serious about security, and we like to frame it as trust. Now, security is just one element of trust. I mean, it's a full team effort. It's not just a technical role in establishing trust. You've got to message it right, and everybody in the business needs to be involved. And if you think that you don't really have time for that, think about what would happen if you allowed all of these vulnerabilities to happen in your app, right? That's sort of antithetical to trust. Knowing your customers, knowing that you were negligent in letting some of these things keep going. And the reason I'm talking to you about this today is to hopefully educate and impart a few things so that you guys can prevent this in your companies. And of course, it's not always the #1 thing that you're always going to be working on. But if it's there and it's in the back of your mind, then hopefully you can catch some of these things before they're a problem. So there's just two specific, and they're pretty common web vulnerabilities that I'd like to introduce. So XSS stands for cross-site scripting, because the X is kind of like a cross. And CSRF, also known as CSRF, is cross-site request forgery. And I'll explain what these mean in a second. And hopefully you know a little bit of JavaScript, and maybe some Node.js would help too. So let's go into cross-site scripting. So cross-site scripting is an injection attack where the user is the person inputting some data, and it's not always the browser, but typically it's the browser or a REST API or something like that. So I made this nifty little diagram showing that the adage of garbage in, garbage out is maybe not that great of an idea when you're talking about security. So if we're not validating, we're maybe storing that garbage, or the dotted line is what's called reflecting it, so that's when you're not storing it anywhere. We're not sanitizing it on the way out, and it gets presented as that same literal garbage. And you think, well, why could that be a problem? The problem is that a user can put arbitrary HTML or JavaScript on your page if you don't validate and sanitize these outputs. So just for an example, this is an EJS template, which I think has the same sort of syntax as is it ERB, Ruby? And you can see that there's two template slots here. There's the username, which is controlled by some user, and the site name, which is controlled by you, the developer. And the dash operator is just straight interpolation, so it just takes the exact value of that variable and puts it into the template. So what happens if someone updates my profile, maybe it wasn't me, I don't know, and they change my name from Jeremy to /h1 script window location evo.com/script. So we got that template, and it gets rendered as, surprise, surprise, a script tag in what would probably be the header of that page. And you can see that, you know, by changing my profile name, I now just can't access that site. I'm redirected over to evil.com, and maybe that's a very convincing clone of my site, and they've just tricked me. So let's learn about how to prevent this. So this is my opinion. There's a lot of ways to deal with it, but just focusing on the way that I like to tell people is that there's 3 steps to it. Validating input, sanitizing output, and in modern and evergreen browsers, we've got this brand new thing called content security policy, which I'm just going to bet a lot of people haven't heard of yet. It's a pretty new thing, but support is pretty good. So here's the updated diagram. You can see that when the user inputs garbage, we're going to validate that, which, you know, if you've been around since JavaScript has been in, that's sort of what it was written for, form validation, hey? And, you know, we're going to store that after we've validated it, or we're going to reflect it. We're going to make sure that when we present it, that it's actually presented in a way that's safe. So we're going to sanitize it, or escape it, or normalize it. And then as a final seal of approval, we're going to put the CSP feature on here, and that offers an extra layer of protection. So this is called the defense in depth, when you have multiple ways of trying to solve the problem, and they're all complementary. So you can't have just one of these, you've got to have all 3. So let's do step 1 here, validation. So the best case, and this is sort of in general for security, is that if you can narrow it down to the list of possible good values, an allow list, that's the best thing. So rather than having it be open by default, you want to have it to be a narrow, known set of values. And this is great for testing and software complexity as well. So for example, I maybe have a form on my profile that's handedness, right? And I don't know if there's other kinds of handednesses, so I put other there. And, you know, maybe this is typical for a select box, right? So there's a bit of a conundrum about this, though, and it's that not everything in life is like you can enumerate them, right? So human names, for example, this is just like, you're going to go insane if you try to validate these. So many different punctuations, you've got Unicode to deal with. Instead, you know, for names specifically, what I like to recommend is that you don't allow angle brackets, which are probably extremely rare, unless someone's got like, you know, angle bracket 3 for a heart or something. I don't know, can you have that in a legal name? So just any character but those, I think. So step 2, sanitization. And the reason why sanitization is important is because what I said about human names, you can't validate absolutely everything. Where you can, you should, but just, you know, this is defense in depth. We've got to have a backup plan for when validation isn't going to cut it. Sanitization is also known as filtering or normalizing and or escaping. So our goal is to prevent user-controlled input from breaking out of its context. So in the first example, the context was kind of HTML text. And by allowing those script tags to show up verbatim, we allowed it to break out of that context. And the means to this goal is to convert unsafe markup to safe markup. And there's sort of two general ways to do that, which I'll go over. So the first one, and this is maybe one you've heard about, is that you can take HTML characters, that like ones that are specially reserved for markup, and you can turn those into display characters, and this is called entity encoding. So here's the basic table. You may have seen this before, and of course you've run across the ampersand one. What a lot of people often forget is apostrophe, which has character number 39. Because this is used for quote, you can also use it to quote attributes. It's also a really good idea to make sure that gets escaped. The exhaustive list is actually everything not in this regex set could be used to perpetuate a cross-site scripting attack. What I advocate is that you go overboard in trying to escape characters. Don't just limit to those ones, because you may prevent it in like some other kind of weird or unusual context, and i.e. would definitely have a problem with a few of these characters. So let's go back to that example. Here's our template again, the problematic user.name. So in EJS, the fix is pretty simple. We're just going to change that to use the escaping operator, which is, it has the equal sign rather than a dash. So that's the escaping operator. And it's, I think in EJS, it just by default does those basic HTML entity encodings, but you can override that to do the thorough one if you really want to. So that changes the output from this, which is really bad, to this, which is safe. So you can see the script tags are now completely rendered useless because we've got display angle brackets rather than markup angle brackets. So you might be wondering, is it just HTML that I've got to worry about? And unfortunately, the answer is no. So this is from the secure filters module that we've got on NPM, which I'll get into in a little bit. But these are the contexts that we've identified in our own applications that we need to cover. There's CSS context, which, again, Internet Explorer and some older browsers used to allow, you can have expression, like the keyword expression, and then round braces, and then some JavaScript. And you can have that execute code in a CSS context. So if you think CSS isn't executable, maybe on some browsers it is. Some other really common ones, you've got two types of JavaScript context. The JS obj one is where you would think you could put JSON, but I'll show you an example of why you can't just put JSON straight there. JS is a JavaScript literal. Style is sort of a hybrid between the HTML context and the CSS context. You kind of have to apply both types of escaping. And especially nasty, we'll go over URI and HTML, but especially nasty is the JavaScript attribute context, which is a whole mess of complicated escaping. So a lot of people will just think, HTML escape it and done. But you can't really do that. I'll show you why just HTML escaping isn't sufficient in a second, but first I'd like to show you why just inlining JSON into a script block can be bad. So we've got this template, and again we're using just the straight interpolation operator because we think that inlining JSON should be safe. The users input that string, and again it's kind of looking suspicious. We've got a closing script tag, an opening script tag, and we're running some arbitrary function. It doesn't really matter what, and in a lot of talks about security, you just pick the alert function since that's nice and obvious, pops up a modal dialog. So when we render that template, and you can see the syntax highlighter here has actually picked it up, is that right after that double quote character, can you guys see that? So right here, it's stopping the script block. So right there is where that initial script block ends. And we've started a brand, like that'll end in an error, right? So your browser will just throw that away. And then you'll start executing this new script block, which will run that arbitrary code. So that's why it's not safe to inline or interpolate JSON directly into a script block. So to cover the next context, or to cover this JSON context too, what we really need to do is apply JavaScript string literal escaping. So you can go \x or \u and put some hexadecimal in there for the code point or character number that corresponds to that character. So instead of outputting that, we would output this. And you can see that because the less than character is now escaped, we're not going to break out into a new script context. So the one thing that a great deal of frameworks seem to miss is that even if you do this HTML escaping, or you're doing a good job and you're doing the HTML escaping plus the JavaScript literal escaping, is that they miss the fact that if you assign to inner HTML, you're undoing that escaping. You're basically telling the browser, here, go and reinterpret this HTML that I'm about to give you. So even though I've done a really good job and I've escaped the less than, when I go and stick that into a span, it's actually just going to run that script. So this is something a lot of people don't realize, and a lot of frameworks that are doing a template type thing seem to think that it's totally safe and they can just plop it right in there, but it's a big problem. So let's move on to the next context. So for URIs or URLs, there's a special type of escaping. So here you can see I've applied that HTML escaping operator, which is going to, when I'm giving it this input, which you can see looks like it's got another query parameter in there, what it's going to render as is this. And you can see, HTML escaping turned the ampersand into ampersand amp semicolon. What the web server gets is two user parameters. Because it's not, the browser won't see ampersand amp, that gets turned into the HTML attribute, and when the user clicks on it, this is what the server's going to see. And depending on the server, maybe it's going to show user 666 instead of the expected 42. So you could use this to trick somebody into clicking and doing some administrative action on some other user, potentially. So for the URI context, what we need to do is, it's called percent escaping. So that's where you take the Unicode character, the Unicode bytes, and you take each byte and encode it as the hexadecimal. So for ampersand, it goes to %26, or 26 in hex. So this is what would get rendered into the template. So instead of the amp, you've got %26. And what the server is going to see is just one user variable, and it kind of looks a little bit like gibberish. And something you've got to watch out for is a parse int in JavaScript is very forgiving. And if you don't believe me, open up a node REPL and try it out, or a console, and just, you can see this evaluates to 42. That's like those Watt talks, right? It's like, what is this doing? So there's a lot of tools to help you with sanitization. So I mentioned secure filters. This is one that I wrote alongside of some other security experts at Salesforce. And what it gives you is, there's two ways to use it. You can just use it as plain old functions, or you can integrate it into EJS. And is that easier to see or worse? So you get this syntax where you can sort of declare what that template slot is going to look like just by putting pipe and then the name of the context. So you'd maybe have that little, that illustration that I had as a kind of cheat sheet. Yeah, right, so all of these contexts, you can just use them as plain functions in any JavaScript framework. And it's just I think we've got it so you can do AMD or require loading of that module. Something similar to it for PHP is, I don't know if it's a package on its own. I'd really have to check with the PHP experts here. But it's at least in this Falcon project, and it gives you the same sort of filter functions like secure filters. Basically, they're a little bit more long-winded, but that's nice because it's explicit. And it seemed to be doing a pretty good job. A second class of preventing XSS and being like automatically context sensitive is where you're actually parsing the HTML yourself, or you're doing it like direct DOM manipulation. So Angular is an example of that, where the handlebars ask operator and the ng attributes, because those are modifying the DOM directly, they're safe. In addition to that, there's this strict contextual escaping service. And if you don't know what service is and haven't used Angular, don't worry about it. But it gives you all of those different contexts that I showed you in the illustration as well. And you can use those just as regular functions like you would in secure filters. React and JSX is the same sort of deal. It gives you an alternative syntax, but down at the guts of it, it's really just manipulating the DOM directly. For Java, you should look into this. It's called the ES API, the OWASP Enterprise Security API. And it's the full meal deal. It has input validation, escaping output, and anti-CSRF, which is the second half of this talk. The most interesting one that I've seen, and they actually took this ECMAScript proposal called quasis, which are now called tag template strings. And it actually parses out that little blob of HTML, and there's two template slots. They just have a dot because it's positional rather than named templating. And it actually knows, because of where it found that placeholder, which sort of escaping to do. So I thought that's really cool, and I like the idea and really want to write something like this for Node or JavaScript. So before we move on to the content security policy, just wanted to talk about, should I sanitize inputs, which seems to be a really common misconception. The reason why you don't want to do this is that if you're saving that data, it's permanently modified, and maybe you've thrown away some useful information. You may have permanently scarred somebody's username, which can leave a really bad impression. Sanitization is cheap, highly cacheable. There's no reason to not do it at runtime. So that's what I suggest. Validate inputs, sanitize outputs only. So let's move on to the new feature in browsers, which is content security policy. So again, this is part of our defense in depth. We've got input validation, output sanitization. Step 3 is content security policy. And that's because we need a fallback. We need to make sure that if something gets by our strict validation and our awesome sanitization, that we've got a last line of defense. So how it works is Pages, or your server, gives an HTTP header or an HTML meta tag, that looks something like this, and it usually won't have the new lines in it. And what you do is for each of these features, like connecting, which is XHR and WebSockets, fonts, frames, media like videos, scripts and styles, you define the exact origins that you want to be able to run on your page. Self is a special keyword for it's the same origin. None, conversely, is nobody, right? So by default, this policy says don't trust anybody. Only allow connections to this special, maybe it's like a socket.io endpoint. And you don't have to put the protocol. So for the media source there, I've left it out, and I'm just saying these two hosts. And let's go into a bit of detail about the script source one. You remember this, of course, where we redirected the user away. We could have prevented that with this content security policy. And what that says is scripts can be only sourced from the same origin. And an inline script block is not the same thing as a script tag with a source attribute. So for example, that policy allows that first one, since it's the same origin, but it would disallow that second one if somehow that got inlined into the page. So that's why this is useful as that last line of defense. And if you really want to have script blocks, you can use this unsafe inline keyword as well. And I like this. There's a secure coding standard out there that says the alias for insecure should never be empty string. So in other words, always label your insecure features with scary words like unsafe. Any tools help with CSP? I recommend, if you're using a Node server, check out Helmet, which provides a way to specify CSP, but it also has a bunch of other really cool features like preventing your site from getting framed, which is that X frame, and setting proper content type options to prevent, you remember before I said Internet Explorer had problems with certain characters? That's due to this thing called type sniffing, where even if you say it's HTML or somehow maybe it's octet stream, it'll just try to deduce the type from the content, and you can turn that off. The other one that I like is this cspbuilder.info, and there's this report-only mode in CSP where you can give it a URL to report to rather than blocking this stuff outright, and it gives you a nice little report of what you should set as your CSP header. So basically, you put this report-only header on first, you load your page, because it notices all of the different things that you're sourcing, it can keep track of it at that report URL. So it's pretty nifty. Just be aware that you are giving the list of those includes to somebody else. I don't know, they might have a Git repo or something to check it out yourself. So in summary, validate your inputs, sanitize your outputs, and turn on CSP, please. So before we go into CSRF, because I know everybody's mind is probably just like mush, right? Fun fact about Victoria, BC, is that we are the retirement capital of Canada. So we're just like Florida, right? Is that the idea? Our motto, our unofficial motto is Victoria, home of the newlywed or the nearly dead. But I mean, we've got a thriving technology community. I mean, we've got TJ Holloway Chuck, and, well, TJ, really, and, but he's like 10 or 12 developers, so that's cool, right? Okay. Thank you. So, CSRF. So, CSRF, cross-site request forgery, exploits the fact that you're logged in to some other site, like with a cookie. So, for example, I'm on example.com. but somehow maybe like an email or an IM link or something else in the same browser, in a different tab, or even in the same tab, I click over to evil.com. And let's just say evil.com has this HTML in it. And you can see that it's got this script block. And it looks kind of strange. It's got example.com API invite admin. And that sort of suggests that it would do something like inviting an administrator to your account. So because of the fact that you're logged in to example.com, even though you're on evil.com, that request still gets authorized because you're logged in. We need to provide some extra protections against this, which is the whole topic of cross-site request forgery. Okay, so how do we address this? So I like to frame it in human terms, and then I'll show you the technical ways to do this. So really, we want to assert that the user intended to do this action, and it wasn't just some automatic browser thing, like an XHR request or a script include. So for example, I like this three-part statement. The user was on my website, they were present. Then they clicked submit on a form, therefore this isn't a cross-site forgery. So let's translate these to technical terms. The user was on my website means that we should put into a form this secret anti-CSRF token, and that's tied to the user's cookie somehow so that we can validate it later, but it's really important that it's not the same value as their cookie. And there's multiple ways to do this. You can use a cryptographic hash function to generate it from their cookie, or you can store it in their server-side session, like maybe you're storing it in a database or a NoSQL or something. So how do we translate? Then they click submit on a form. So the REST architectural style, which is what HTTP is based on, says that any actions that change application state should be one of these verbs, post, put, delete, or the newest one is patch. And they would prevent that script tag that we saw at the beginning, where it's just doing a get instead of a post to retrieve that script. On its own, though, it's not enough to stop CSRF, but it at least stops that trivial case where someone is just putting it in the script tag. So how do we translate? Therefore, this isn't a cross-site forgery. We're going to validate that anti-CSRF token, which we know was secret. An attacker couldn't have put it on their site. And because we can validate that and their cookie, we know that the request is legitimate. And it's really important that you use HTTPS, because if someone's able to sniff that CSRF token, it's the same thing as them knowing it, right? So how do we fix our broken site with the invite admin API? So I'm just going to use Express, not just because of TJ, but because that's what we use. And I'm going to change this invite admin endpoint, which I'm saying only has the get verb. I'm going to change it to just post. And Express, the way it lets you access the parameters, maybe you don't even have to change the handler function. The next thing I'm going to use is in Connect, there's this CSRF middleware. And there's some other independent node modules that do a very similar thing. It might even be baked into your server-side framework. But for Connects, you load it after you've set the session middleware. And what it does is it stores a CSRF secret, which is kind of like a salt value. And, sorry, it's a secret, which is a key to an HMAC function. And in the page, it'll actually embed a salt and then the HMAC result. So this is actually, if you've ever heard of the breach attack, which is a compression oracle on HTTPS, don't worry about it. That Connects is also resilient to that. So how do we access that token? We've got to use this in a second in a template. So how you use that is it's just this CSRF token method on the request object. So you put that into your template. So let's change it. So maybe this is what was literally on our site that caused, enabled the CSRF, right? This seems like a reasonable feature, except our form is using method get. And of course, there's the email that we want to invite. So let's change this to a post. And we're going to inline that CSRF token. And you notice I'm using the interpolation operator, which is okay because that template slot is not user controlled. We generated that. So that's the like automated way to verify that we're not getting CSRF'd. So some other ideas to do this a different way is to just ask for confirmation. Like if it has to be like a gettable link, like show them a page that has a postable confirmation. This is a really good way to make sure that it's a human. And of course put the CSRF token in that page. For really sensitive stuff, I like how GitHub does this, where if you're doing something in the admin section of your repo, it'll actually reprompt you for your password. And the reason why this is good is that it's just too easy to leave your browser open for a long period of time, and maybe you don't lock your screen, and maybe somebody comes along. This way, to do that really sensitive thing, they need to know your password too. So in summary, YouTube can prevent CSRF fires. Verify intent. Did the user do this action? Be a good REST citizen. Make sure you're using post or put instead of get. And make sure that you've got anti-CSRF tokens enabled. So in conclusion, trust should be, it's our number one value. It should be somewhere on your list of values too, because if you don't have your customers' trust, maybe you don't have customers. Ignore that parenthetical on number one. So cross-site scripting, let's just recap what you needed to do. There's 3 steps: validate inputs, sanitize outputs, remember not to sanitize inputs, and mix those 2 up, and use this newfangled thing, content security policy, CSRF. The overall idea is verify that human intended to do this. Be a good REST citizen, which is post and put and delete and that sort of thing, and use anti-CSRF tokens. And so that's my talk. The slides are up on GitHub as the reveal presentation. And thanks to GoInstant for sending me here. We make a real-time backend as a service, and we're very serious about security. Thank you.